Hello everyone. In today's video, let's take a look at a question regarding cubic equations. Here comes the question. Say a and b are two real numbers and they satisfy two equations. A cubed minus 6a squared plus 13a equals 13 and b cubed minus 6b squared plus 13b equals 7. Find the value of a plus b. When I saw this question, I noticed both of the two cubic equations do not have integer solutions. I made this conclusion based on very useful lemma, that is, let px be an integer coefficient polynomial whose leading coefficient an equals 1. If px equals 0 has an integer solution x0, then x0 must be divisible by the constant term of px, which is a0. In other words, if any factor of a0 is not a solution to this polynomial equation, then that means this polynomial equation does not have any integer solutions. This lemma is very useful to judge if a polynomial equation has an integer solution. So from here, I know it's not possible to solve the problem to get the value of a plus b. I have found another way. I noticed the left sides of the two equations are the same, but their right sides look quite different. So I decided to do some number manipulation by writing 13 as 10 plus 3 and 7 equals 10 minus 3. Then the original equations become a cubed minus 6a squared plus 13a minus 10 equals 3 and b cubed minus 6b squared plus 13b minus 10 equals minus 3. Okay, without any surprise, I define fx as x cubed minus 6 times x squared plus 13x minus 10. I want to know if this function can be further factorized. Then, by using the same lemma that I just mentioned above, I'm checking if any factor of 10 is a solution of fx, and I found out f2 equals 0. That means x minus 2 is a factor of fx. Then I need to know what's the other factor of fx. Well, this can be done by doing a long division. Here is the process of doing the long division here. I'm posting here, but I'm not going to repeat. You can take a look if you are interested. So in conclusion, fx equals x minus 2 times x squared minus 4x plus 5. And the latter factor can be further written as x minus 2 squared plus 1. I notice that x minus 2 appear twice in this equation. Then I'm going to do a substitution here by letting x minus 2 be t. Then this function fx can be further written as f t plus 2 equals t times t squared plus 1 equals t cubed plus t. And I'm going to give this new function a name, gt. Then the original equations fa equals 3, fb equals minus 3 become ga minus 2 equals 3, gb plus minus 2 equals minus 3. So what's special of this new function gt? I notice it has two very important properties. First of all, it's an odd function, which means minus gt equals g minus t. And second, it's a strictly increasing function, which means if t1 is larger than t2, then gt1 is larger than gt2. Those two interesting properties combined together leads to a very useful conclusion. That is, if for two inputs of gt, if their outputs are opposite numbers, then those two inputs or those two variables must be opposite numbers too. And in this question, we know 3 and minus 3 are opposite numbers. Then the only way to satisfy those two equations is the two inputs a minus 2 and b minus 2 are opposite numbers, which means b minus 2 equals minus of a minus 2. And finally, we get a plus b equals 4. And that's the answer to this question. This problem gets resolved. Thank you.